Hi and welcome back. So in this video we're going to do a problem exactly like the last problem. So if you want to try it on your own, I'm not going to go through all the algebra behind this problem. I'm going to go, if you want to see the algebra behind what I'm doing here, you might want to rewatch the last video from problem 19. But what we're doing is we're given a function, x of t, which is equal to 3 cosine 2 pi t plus pi over 7. And what we're supposed to do is represent this as a sum of complex exponentials. So that's the problem. Anyway, if you want to try it, here's a great time to pause the video. And now I'm just going to go through with solving this. So if you remember from the last video, or if you saw the last video, or if you want to see the algebra behind where I'm going to get this result from, what this becomes when it's represented as a sum of complex exponentials is going to be, or let me actually write this in a general sense. If I have a function x of t, which is equal to k cosine 2 pi t plus pi over 7. Oh, sorry, I should have said general. Omega t plus phi for phase. I found out in the last video by doing all of that algebra that this could be represented as k over 2 e to the j phi times e to the j omega t plus k over 2 e to the minus j phi e to the minus j omega t. That was the big thing we figured out in the last video. If you want to see all the algebra behind getting this, and it's a really good idea to go through that. So if you ever forget this on an exam or something, you can go through and reprove it to yourself again if you need to do that. This is pretty much the thing that we arrived at in the last video. So if you want to see that, it's a good idea to go back to the last video. That was problem 19 and see the derivation of where this comes from. So now, pretty much if I know this, I can just go ahead and plug and chug with these numbers, right? I know just from inspection that my k is equal to 3, my omega is equal to 2 pi, that's my coefficient multiplying the t, and my phi, my phase information, is just pi over 7. And so now I just pretty much plug those into this expression. So I can say that my function x of t can be represented as k over 2, so that's 3 halves, e to the j phase, so e to the j phi, e to the j pi over 7, times e to the j omega t, e to the j omega is 2 pi times t, plus k over 2, so k is 3, 3 halves, e to the minus j phi, e to the minus j pi over 7. Pi over 7 is my phi. E to the minus j 2 pi t. And that's it. That's the answer. Hopefully you found that useful. If you need to see where this comes from or get more information about how exactly you do this or a bit more in depth in the problem, great idea to rewatch the last problem, problem 19. So anyway, thanks for watching, and I'll see you in a future video.